So everyone, let's do this. Work, positive or negative? Can you remind me again what term in the equation made it positive or negative? What term in the equation for work was the reason things could be positive or could be negative? Was it the F, the delta D, or the cosine term? The cosine term. So let's write due to the cosine term, due to the cosine term. Okay, there are 5 cases. Some teachers teach it as 3. Now, I like to be more detailed. 5 cases. There are 5 possible outcomes for the work done by, not by a sum, by some specific force. Okay, I like to call them this way. And by the way, those names will make sense. Fully positive. When does the fully positive case happen? When your angle theta is exactly 0 degrees. Okay, I'll explain what this means. When theta is equal to what? 0 degrees. Okay, that would be the case we call what? Come on. Fully positive. You'll understand what fully positive means. Then, what's lower than fully positive? Partially positive. This is when theta is what? Bigger than 0, but less than what? Less than 90 degrees. Thank you. So theta, does anyone know how to write that in mathematical notation? How do you write some number is bigger than a number, but less than another number? Like if I told you 5 is bigger than 1, but less than 10. How do you write that in math set notation? Or yeah, the inequality, the less than or equal sign. What do? You write the what? Look, this is the way I always memorized it. You write the theta in the middle. Now, which one is the low end, the 0 or the 90? 0, yes. So 0 is here, and 90 is here. So 0 degrees, and here 90 degrees. And what do I write? Bigger than or less than here? Here is bigger than, and here is what? Less than. Does that make sense? See, in this statement, you're really saying how many things? 2. You're saying what? Theta is what? Bigger than 0. And here it's what? Theta is what? Less than 9. In one shot, you say 2 statements. Okay? By the way, question for you. Can I do this? Nothing. Thank you. I've already accounted for the what? This case had its own what? Had its own thing. Okay? So go ahead and just make it. Yes, but I've already made what? I've already made a case just for the what? Just for the equal case. So we're good. Okay. What's next? Come on. You have it in your notes. 0. 0 is when you hit exactly what? 90. 0 is theta equals 90. What do you call any 2 things that are 90? Right angle, or 2 things are? The angle is right, but the 2 things are what? Perpendicular. Don't say normal, because we already discovered normal. Normal, we keep it to forces, okay? Perpendicular. P, E, R, E, E, N, D, I, C, U, L, A, R. Okay. Who's got the case number 4? Partially negative. Okay. Come on. We've done the 0. We've done between 0 and 90. We've done 90. Where are we now? Bigger than 90, but less than what? Exactly. See, by the way, do you see why circles are very important? We were at 0, and then we were between what? Between what? Come on. Between 0 and then we hit what? And now we're going to be between 90 and what? And then we're going to hit what? You see, that's why it's 5 cases. Okay? So partially negative is, okay, how do I change this statement to be here? 90, and 0 turns into 90, and 90 turns into 180. Basically, each small end becomes the other small end. So 9 is here. Theta, 180. Okay. What's the last case? The perfect 5th case. You exactly hit what? The ground, which is 180 from the other side, though. So fully negative, which is theta is a dead-on 180 degrees. Those are the 5 cases. Okay. So let's what? Let's talk about each case in detail. Each case will take us like maybe 2 minutes, and that's it. All right. Everyone, let's go to the next slide. So, case number 1. Can you tell me what does it? Okay, you know what? Yasmin, I'm going to use you for an example, if you don't mind. Everyone, can you just hold your hands up? Okay, everyone, what did I give Yasmin? 2 what? 2 pencils, which resemble to what? vectors. I want you to hold these two vectors such that, we'll see how this makes sense, such that there's a zero angle between them. I want to see how you guys understand, ladies and gentlemen, understand what does it mean for two vectors to have zero. Okay, hold on. Can you lift it up? Zero angle. Does anyone have any comments about that? That looks like 90 to me. Well, what's so bad about the way she's holding it? Are they going together or against each other the way you're holding it? Against means what? I want you to hold it fully positive. I love that. Everyone, look. Can I ask you a question, Hannah? Okay, hold on. Do you want to keep it with this orientation or do you want to change it? By the way, vectors are important because they have a beginning and an end, so it's distinct. Nope. Nope. By the way, question for you. Why? No, everyone, guys, Ali, why did you, Hannah, why did you stick them together? Is it because there's a zero angle between them? You see, the beautiful thing about this one is this, remember, vectors can be stuck together or what? Not like separated, as long as their orientations stay the same. Zero doesn't mean what? Zero angle does not mean 0 meters. That would be 0 meters between us. Do you see what I mean? Question for you, everyone. Let me show you the easiest case. Everyone, eyes on me. What about this one? Definitely. Does anyone have any issue saying that this one is 90 degrees? How many people agree? Raise your hand if you agree that the angle here is 90 degrees. No, let's say 90 degrees. Okay, question for you. Can you guess the angle now? Say again, 135. Can you guess the angle now? Are we good so far? Okay, I'm going to go back to what? How about now? How about now? There you go. Do you see what I mean? So an angle of 0 between vectors just means they're what? No, this is not parallel. There you go. So did you have to hold them stuck next to each other? Just this. Because remember, as long as I move vectors where they don't what change their magnitude or direction, can I do anything with them? Are those vectors still the same? No matter what I do. Yes. How about now? Oh, what just happened? This one changed its what? Its direction. How about now? Oh, this one changed. Do you see what I mean? As long as they don't change their what? Their size or their orientation, you can put them at any separation you want. Can you still put them perfectly together? You can, but do you have to? You see, now you understand the difference between 0 meters and 0 angle or 0 degrees. 0 degree just means what? They're parallel. They're parallel. Perfect. Yes. Which makes sense because now what's happening to the angle? It's what? It's what? It's increasing, which means if it decreases, what's the smallest angle you can ever get? 0. You got it. Okay? All right. So what we got right here? We got right. When the force and the motion are exactly in the what? In the same direction. Thank you. In the same direction. The angle between the force vector and the displacement or motion vector is what? 0 degrees. How could your FBD look? Does that make sense now? Okay, everyone. You've done FBDs now for like 3 weeks straight. What force usually pointed with motion? Applied. What else? Come on. Come on. I'm just trying to give you examples here. Tension, if you're pulling like the pulley system. Would friction ever be like this? No way. Friction would be which case? See, now you're relating what? Today's lesson to what we've been doing for 3 weeks. How about normal? Yeah, well, okay, at least in grade 11, yes, it is. How about gravity? It's also what? But going which way? Which? Do you see what I mean here? So what are good candidates for a force that's always pointing with motion? Applied or no, tension. Okay. Now here's my question to you. Everyone, let's calculate W equals what? F times what? Delta D times what? Okay. Am I giving you any numbers here for the F? Come on. Am I giving you any numbers about the newtons for the F? Like okay, everyone. Does this diagram tell you anything about the magnitude of the force? Does it tell you anything about the magnitude of the distance? But does it give you information about the size of the angle? What's our size of the angle? All right. So I can't do anything to the F. I can't do anything to the delta D. But I can for sure switch the theta to a what? We have the value of the variable. Let's plug it in. Equals, come on. F delta D cosine of what? Come on, get me the cosine of 0. Go, go, I know it. Nope. Oh no, oh no. If it were 0, all the universe would break down. Go, go, get me cosine of 0, people. Get me cosine of 0. By the way, this will really help you out understanding for grade 11 and 12 function. How many people are getting 1? Is it like an approximate one or a perfect one? It's a perfect one. Is it a plus or a negative one, though? So what do you conclude? You can replace this guy, not just this, no, this guy with just what? Hey, what do you get when you multiply anything by 1? Do you get 1 or the same thing? 1 second. Yeah, go ahead. You get the same thing. So, I have a question for you. You too. I have a question for you. Can someone tell me what's 1 in percent? What's 1 in percentage? Nope. Okay, everyone, does anyone know how to go from any number to a percentage? If I told you 0.5, what's 0.5 as a percentage? 0.5 or half. What's 0.5 as a percentage? 50%. How did you go from 0.5 to 50? Times it by what? So what would be it in the case of just 1? 1 is what? 100%. Now you know why I call this case fully positive? Because that means what? Everyone, question for you. If your force is this way and your motion is this way, are you wasting any of your force or is it perfectly going with motion? What does that mean? Are you wasting some of your energy or are you fully using it to push the box where you want to push it? That's why I call it what? Fully positive work. Fully positive work. None of it is what? None of it is what? Wasted. Yes. By the way, again, this will be immensely important in understanding the solution to your problems in grade 11, grade 12, and first year. All right. So that means what? Max positive. Max. Thank you. Yes, at least that force is not being wasted. Maybe other forces are, if there's more in the FBD, but that one is fully utilized to. Why do you think we have 5 different cases? That's why. Yes. Okay, so max positive, which means what? No, none of this force is wasted. That's it. Okay, let's go, everyone. Let's go to the second case. What's up? Nothing. Oh, again, what's plus VE? That's notation for what? Positive. Maximum positive. Hold on. Okay. What? No, no. This is not a symbol. This is just the physics and math shorthand way of writing the word positive. That just means maximum positive work. Like all of it is being used up. None of it is being what? Wasted or spent incorrectly. That's all. Again, everyone, when we do advanced problems, I'll explain to you what this means more. But today, let's just say that this means what? Max positive work is what is used up. Okay, let's go to the next one. What's my next case? Come on. Partially positive. What was the okay? But I want you to hold these vectors in such a way that they have an angle anywhere between 0 and 90 between them. Don't you dare touch 90. Because I'm saying what? Is this equal or strictly less than? All right, you can't touch 90. You cannot be 90. That's great. Okay, lift your hand up. Everyone, do you agree that the angle between the tail to tail that are there is between 0 and 90? Yeah, what's your guess? Like roughly what? 30 degrees, for example? Good, thank you. So that means what? My question to you is, keep holding it that way. Are they going perfectly in the same direction? Perfectly. But are they generally going in the same direction? Thank you. So I can't say exactly or perfectly. I have to say what? Generally or somewhat in the same direction. Nice. Yeah, that's it. We're good. So when the force and the motion are generally, or sorry, somewhat in the same direction, the angle between the force vector and the displacement vector is between 0 degrees and 90 degrees. Okay? All right. So how does my diagram look now? Well, it's kind of gonna look like the first diagram, but my force is gonna be what? Perfectly parallel or slightly tilted? Can someone give me an example of a force that goes like that? By the way, again, I'll put your minds at ease. Have I ever given you so far a force at an angle? No, all your forces were what? Either perpendicular or what? In the same direction or what? Oppositely directed. Hey, come on. I got it. I got it. Yeah, I got it. You're good. Okay. Can you give me though a force that could point like that? By the way, if anyone is feeling uneasy about this, you should, because you probably are like, how could I pull with a force like that and it ends up moving like that? Do you see what I mean? That just means what? No, but hold on though. If the only force, okay, everyone, question for you. Imagine this box to be in deep space and the only force on it was pointing this way. Would it ever move this way? It would move which way? With the force, right? So what does this mean? There are other forces in the mix. I am just what? Isolating me looking at one of them. Do you see what I mean? There are other forces that somehow are canceling and fighting, but the eventual motion of the object is which way? That way, okay? But my question to you is, this particular force, everyone, is it being fully used up or somewhat wasted? Why? What's your conceptual reasoning that some of it is being wasted? Oh, okay. Forget gravity, forget normal, forget all other forces. Why is this force partially wasted? Or I guess partially used in the same. It's not going perfectly in the same what? In the same direction as the what? As the motion. Is some of it going with it though? Yeah, some of it is pulling right, but some of it is pulling what? Up. Which means what? The up part is what? Used or wasted? But how about the right part? Do you see what I mean? So is this going to be the fully max positive one or the partially max one? Yes, sorry, partially positive. Why? Because some of it is used, but some of it is what? Wasted. Good, good. Okay, and I'll prove to you why mathematically. So let's what? Start with the same thing. Yes. Go ahead. Yeah, we're going to do the same derivation. Okay, so let's start with the same way. Okay, I'm going to do it with you. W equals, where's my thing? W equals force times delta D times cosine of theta. Okay, now I want to do a little discovery with all of you. Everyone, I want you to give me a bunch of angles that are between 0 and 90. Go ahead. Let's make a table. Come on. Sure. Theta, 4 degrees. Keep going. Come on. Jump. We have until almost 90 to finish. 16. Come on, get close. No, you. All right, go ahead. Get me the cosines. Go, go, go. Come on. Get me all the cosines. Okay. Are all of these angles, Walid, between 0 and 90? Good. So they're all good candidates. Great. Cosine of 4. Sure, sure. Come on. Yep, that's fine. 16. I'll take that. Sorry, 0 point. 1 point. So 156. No way. 89. Oh, 0.0. Yes. I want you to tell me the two main features of all of those values. Okay, I agree with that. But give me two features that are common to all of them. They're all decimals under 1, and they're all also what? Negative or positive? Okay, question for you. Let's make all of them percentages. What's 0.017 in percentage? No, not 17. You're multiplying by 1,000, my friend. Just move it how many? twice. Once, twice. So just how much? Keep going. How about this one? Keep going. Keep going. Keep going. Did any of them make it to 100%? What does that mean? That proves indeed that that force, because of that cosine term, is going to be fully used up or partially used up, which means some of it will be what? Lost or wasted, no matter how what? How small. Why is this one? Which one of these would be mostly the best one to be used up? Why? Because it's almost what? Almost parallel. Do you see what I mean? The more you deviate, the more you're getting what? Used or wasted. There you go. What's your perfect waste when you hit not 89, but exactly what? Do you see what I mean? Do you see how this now makes sense as far as saying, should I really tilt my force that much, or should I strive to always be what? Parallel with the motion. Why would you go like this if you want to move there like that? Question. Okay, everyone. I want to push this, everyone, towards those guys. Is this good? I mean, technically, did it move closer to them on this axis? It did. But was that the best thing I could do? What did I do? I wasted so much of it moving what? Perpendicular to where I want it to be. So where's the best way? Go with the motion if you can. Do you see what I mean? Perfect. Yes. All right. So cosine. So cosine of, let's write just what? F delta D. Now here's a question for you. What do you call any angle that's definitely between 0 and 90? Come on. Acute. So let's put what? Cosine of any acute angle. What did we say about all of these numbers? They're all what? Decimals that are also what? Negative or positive. So that means what? Equals F delta D times what? Positive decimal. A positive decimal. Which means, are you maximum positive or just positive? Just positive. So we're going to say what? We're going to say positive, but less than max. Sorry? Yeah, VE is just a shorthand way of saying positive. That's it. In any math or physics context. I'm sorry? No, because I'm saying positive, negative, positive decimal. It's a positive decimal because I have to say it's positive decimal because we're going to get into the case of what? Decimal, but what? There you go. You got it. Oh, no, no. But I'm here saying it's saying what? Positive, but less than max. Not all of it is being used. No, no, everyone. VE is not a... Okay, everyone. VE is a part of the word plus VE, which is positive. That's all. It's not a symbol. It's just positive the way they just shortcut it. Okay, would it make it easier for some of you if I just wrote plus instead of plus VE? Yeah, that's fine. It's a notation. As long as you understand it, I'm fine with that. Okay, what's case number 3? Right at what? No, exact 0, which means right at 90. Okay. What do you call any two things that are 90 degrees to each other? Ah, perpendicular. Thank you. So when the force and the motion are exactly perpendicular, perpendicular. Me? Or, okay. The angle between them is? Come on. What forces are like this? Usually. Come on. What force usually pointed that way? Normal. How about if I flip it upside down? There you go. Okay. Start with the same thing. W equals F delta D cosine of theta. F delta D cosine of what? Would you like to guess cosine of 90? Can you kind of prove it to me from the table I put on the board? You said it. Look at what the values are approaching. What's happening to the values, everyone, of the cosine? They're getting what? Lower and lower and lower. Eventually, they're going to hit exactly what? A perfect nothing or zero. Nice. So when you multiply anything by zero, what do you get? Come on. Zero does what to any number, no matter how big or huge, that it multiplies. It what? It completely what? Kills the whole thing, right? By the way, give me a huge force. Do you remember the force between the Earth and the Moon? Do you remember what it was? 190 billion newtons. Yeah. Do you think when you multiply 190 billion by zero, you could get something? What does zero do? Completely annihilation. Mortal Kombat stuff. Zero. Finish him. So, okay, hold on, everyone. Listen. This, guys. So should this should sound weird. How much work is being done? How much work is being done? Does that mean that the force doesn't exist? Uh, is the force still in the diagram? And if it's in the diagram, does it also exist in real life? Thank you. So what? Okay, everyone. What's a take-home message from today? What's the conclusion? What's the conclusion you should always understand? Listen up. What's the conclusion you should always understand? If a force that's still real and present gives you how much work? What does that tell you? It tells you that the force is two things. Number one, it's what? Perpendicular to what? Which means all it's doing is it pushing the system forward, pulling it backward, or just supporting it? There you go. Everyone, look. Everyone, how many forces are on the marker right now? Come on. It's not moving. So how many forces? Fg and okay. Obviously, is there motion here? Not yet. So there is no what? No work being done. Because work needs what? Work needs motion and, well, force itself is not enough. Okay, everyone. Okay, what forces are on the marker now? Did the Fg and the Fn vanish or are they still there? Okay, but what two forces are now introduced? Applied force and friction. Okay, but okay, is it moving with applied or with friction? And is friction with or against the motion? Okay, but are Fn and Fg still perpendicular to the motion? So what are they doing? Are they stealing energy from the system, adding energy to the system, or doing nothing to the system? Thank you. They're supporting that it doesn't go up or go what? So does that make sense? So any force that does what? 0 joules of work, I like to call it a support force. What does that mean? Neither with nor what? It's perfectly what? Perpendicular to the direction of motion. Okay? Does it mean it doesn't exist? It exists. It's just what? Not what? It's like you standing outside of the system. Do you still exist? Am I contributing anything? Am I stealing anything? That's exactly what a 0 work force does. Okay. All right. Next. Oh, what should we say after 0? No work done. Go ahead. No work done. No work done. Okay. Yasmin, what's case number 4? Quattro. Oh, you are jumping ahead. Partially negative. Can you tell me an example of a force like that? Come on. Hold on. Friction is never tilted. Friction is always perfectly what? Perfectly what? Against motion. It's not tilted. It's against motion. What could be a force like that? I'll give you a hint. Has anyone? Okay. I guess horseback riding. How is the horse moving? That way. But what are you doing? Or the what? Santa Claus, right? The sled. It's moving this way, but what's he pulling on? What force is that way? What's no, it's not. It's applied in the ropes. So what do you call it? Tension. Do you see what I mean? Tension Could be like that. Is it making sense? Have I ever given you a problem like this? No, because it's what? It's got an angle. You see what I mean? Tension usually went what? Either with the motion or what? Or again. But technically, could okay, everyone. Is this tension? And is it with or against motion? Okay, how about now? Oh, see, I was pulling way too much. Okay, how about just this? Is this exactly that? There you go. So tension could be what? Could be tilted, right? There you go. Nice. Okay, but can someone now give me angles like that? Come on. All of these are wrong now. Come on. Get slightly small first. Nope. 91. You see, we just want to clear the 90 first. So what? 91. Come on. Now we go bigger. 100. You crossed it. You crossed it. Yes. And all right. Get me all the what? All the cosines. I don't care what they are. They will also be what? Decimals. But they will be what? Obviously, there gotta be different numbers, of course. Now, yeah, negative. See, the 91's gotta be negative, a very small number. How much? Yeah, it's the same thing. Because this was what? This used to be what? 89. Sorry, 91. This is now what? 91. It's like you just, everyone, look, you just went from here to here, right? 89, 91. You just crossed the 90 bridge, right? And so on and so on. Okay? All of them are what? Negative, and all of them will definitely be what? There you go. Let's do it. So when the force and the motion are somewhat in the opposite direction, somewhat, they're not perfectly against each other, they're somewhat against each other. Is between 90 and 180. Can someone tell me what do you call any angle that's bigger than 90 but less than 180? Up to. So W equals F delta D cosine of theta, but it's got to be equal to what? F delta D cosine of obtuse, which means what? What are you going to get now? Again, sorry. This part is what? Negative decimal. That's what we're going to multiply with. So it's equal F delta D times this, which means what? You're losing. Yes, of course. Again, everyone, look. Everyone, if you're trying to move it this way, look. Everyone, imagine if Yasmin is trying to push this way. Sorry, actually, no. Yasmin, okay, come up here. You don't mind, thank you. Okay, I'm actually going to tilt it this way. Yasmin, try to pull on it like with both hands this way. Just move it this way. Okay, am I doing anything? No. Keep moving, keep moving. What am I doing now? She's still moving it that way, but am I supporting her? Sorry, am I supplying her with energy or stealing from her motion? Which means what? Am I adding energy to the system or taking it out? And that's why the answer has to be what? Negative decimal, which means what? Now, is that the worst? Okay, what if Yasmin, everyone, sorry, Yasmin? Okay. Well, am I a worse enemy now? Yeah, why? Because I'm not wasting any of my force. I'm what? She's trying to pull this way. What am I doing? Look, am I perfectly canceling her force? How about now? I'm not canceling because I'm wasting some of my force. Do you see what I mean? Whenever you have an angle, you're wasting some of the force. Okay? All right? So what would this be? Can someone remind me what we wrote here? In the case with the what? With the acute. In the case for the acute. What did we write? Like, I just want to make them look the same. No. Perfect. So we're going to say what here? Negative, but less than max. Yeah. Okay. Last case. What is the last case? What's your angle in the last fifth case? 180. Perfect. 180. Perfect. Come on. What force always looks like this? What force always goes against motion? Friction. Could it be tension? Yeah. Remember what Yasmin did? Yasmin was applying a force, and I was applying tension backward. Keep going. Move it, move it, move it. You can just pull on it this way. Yep, yep. Yeah. Now I'm applying. Now I'm trying to pull it back, but she's stronger. Thank you. Perfect. That's it. Okay. Oops, my bad. So double. Oh, hold on. When the force and the motion now are exactly. Come on. Yeah. So everyone, take out the in opposite directions. Take out the in opposite directions. The angle between them is exactly 180 degrees. Okay? W equals F delta D cosine of theta, which is equal F delta D. But what's exactly my theta now? Come on. What's my theta? 180. No approximation. Perfect opposition. Would anyone like to guess what's cosine of 180? Yes, cosine of 0, everyone. Cosine of 0 was fully positive 1. Cosine of 90 was 0. Cosine of 180 would be what? The other case, sorry, the other side. Yeah. You see how this? Oh, okay. 0 again, 1 again. See, cosine is just how far horizontally you are from the what? From the 0, and sine is how vertically up and down you are. This is grade 11 functions, and now you have another way of seeing it more than the students who are in the course. Because I'll be completely honest with you, sadly, trigonometry, the unit circle, is one of the most poorly taught concepts in trig. But oh my God, how easy it gets when you just keep using this 24/7. Yes. I'm sorry. Whoa, when? Couldn't you just make me just finish the lesson and feel happy before you tell me that? Damn you. What's cosine of 180? A negative 1. What do you get when you multiply a number? Hold on. We'll just push it. Guys, I'm still around. Okay. It's okay. What do you get when you multiply a number by negative 1? Well, when you multiply it just by 1, what do you get? You get 100%. How about if you multiply by negative 1? You just, yeah, which means what? You get what? Maximum, but what? Against you. You see what I mean? That is a force going fully against you, right? Not wasted, fully against. So we're going to say what? Max negative. Max negative this time. So max negative. Done. That's it. Everyone good? Okay. Okay. Okay, so let's summarize them. Everyone, if motion and force are generally what? Against or together? Together. The work is always what? Negative or positive if they're pointing together. So are generally together. Sorry, let's say generally parallel. Generally parallel. There's no such thing as generally parallel. I should have said generally in the same direction, but let's just say generally parallel. Come on, generally parallel. The work is positive. Okay, how about the next case? If they are generally what? Not instead of going together, they're going what? Opposite. No. Opposite. So generally opposite to each other. Opposite to each other. The work is what? How about the last case? If they're exactly perpendicular, it's neither positive nor negative. What's the only number between all the positives and all the negatives? Yep, it's the center of the number line. Yes. Second step. Work. Okay. All right. Okay, everyone, let's just do one example. Come on. So, no, this is legit. Just plugging in numbers. You can't tell me you're too tired for that. Okay, can you give me 1 minute? All right. A person cutting a flat lawn pushes. What does that mean? No, there's definitely what? A force applied. There's definitely gravity. There's definitely what? Come on, gravity and normal. Is there friction? By the way, do you think we really need to sketch an FBD for this one? No, I think we have all the numbers we need. Do we know how much force is being used? How much force? The magnitude. Do we know the force magnitude? 125 newtons. Do we know the amount of distance it traveled? 12 meters. Do we know at what angle they were pushing? Do we have all the numbers we need for the work equation? Done. Let's plug in. W equals F delta D cosine of theta. What's F? 125. What's delta? Oh, everyone, again, is this a kinematics problem or a physics problem? Which means what? Your units have to be what? Could they be anything you want or standardized? They have to be standardized, which means force has to be in legit what? Force. Newtons. And distance has to be in what? Meters. And angle has to be technically in what? Degrees. Okay? All right. 12. Can someone get me what's actually 125 times 12, 250, 1500? Yeah, it is. No, hold on. You want to see how easy that is? You guys don't know tricks. That's all. I just know tricks. Everyone, look. What's my number? 125 times what? Okay, I'm not a big fan of 12. Give me two numbers that multiply by to 12. No, multiply. 6 or 2 and 6. Hey, I know this one. What's 25 times 2? 250. Times 6, which is 1500. Sorry, I know. There's always a trick. Oh, I'm finished. Yeah. Can someone give me cosine of 40? And negative or positive? Does that make sense? Everyone, are you pulling on the lawnmower as it's moving away, or are you pushing on it? So is your force and the motion generally against each other or with each other? Which means, is your work done negative or positive? Come on, positive. Why? Because your angle is here, because your angle is 40. And when you're 40 or you're in this quadrant, all of the trigs are what? All of the trigs are, especially the cosine. So it makes sense. Say again? No. And okay, everyone, listen up, guys. Yasmin saying, I don't get how an angle could be. It's not the angle that is negative. The cosine of it. The angles are always what? Positive. The angle is just how much you turn, right? Okay, now you're asking me, what does the cosine mean? Cosine is cosine of an angle. Tells you if the angles are the right side of the grid or the left side of the grid. Where is 40? Yeah, positive 40. There you go. It's positive. Done. That's just one way to look at it. The angle or the cosine. That means your angle had to what? Had to cross to this side, which is gotta be obtuse. Okay? That's, by the way, so many grade 12 and first year students do not know that fact. Do you know, if you go right now to Western and you ask people, hey, what's cosine? All of them will just say what? Oh, it's adjacent over hypotenuse. You're like, yeah, but what is that? And none of them will be able to say more than that because they have no idea what it means. I tell you what it means. It's basically what? where you are in the universe. Okay, what was it? Point what? I'll take that. So how much is the answer? 1500 times 7.76. How many? Okay, first of all, units. Is it newtons? It can't be newtons because we've already used the what? We've already used the newtons. Also, we're calculating what? Which is work. How do you measure work? In what? In joules. Okay, sig figs. How many sig figs here? I have to cut right here. What does the 9 bump up to 4? To what? Full marks. Can someone tell me what answer they provided? What? In 1.15 what? Kilojoules or 1,000 joules, which is exactly the same thing. By the way, we're gonna. No, that's scale notation. Kilo, mega, giga, tera. We're gonna play a lot with them when we do what? When we do scales next week. And that's it. Well, if you round it to what? What do you mean 50? No. Rounding doesn't have to be decimal. Rounding means what? Choose a place to cut and then you round. You see what I mean? Rounding doesn't always have to be with decimals. Rounding means cut it somewhere and decide if you're going to bump up the number or keep it the same. That's what rounding is, not always with decimal. I know most of the time it happens with what? But it doesn't have to be always like that.